So in this video I'm going to discuss about the heat of formation. Related to that, as you guys all know, in the previous video discussed about the types of enthalpies, and there was the one reaction, heat of formation. And I'm going to discuss about that how to solve the problem. Alright, so first, for the very first problem, if I talk about, so that is basically the calculate the heat of formation. Calculate the heat of formation, and the product should be 1 mole. Alright, this is the heat of formation. Calculate the heat of formation of a compound ethylene, that is C2H2, or acetylene on the given thermochemical equation. I'm having 4 equations. Let me write, then I'm going to understand properly. I'm having second reaction. This is a combustion reaction, and the mole should be 1 mole of the reactant, remember? So let me write first of all H2O, C2H2 plus 5 upon 2O, 2 carbon dioxide plus H2O. If I talk about the heat of them, so that is basically the 395 kJ mole minus 286, and this one is also, so you can see all are the exothermic reaction. So the question is that I'm having 4 equation, and I'm having 3 I'm known about their heat, changes of heat, but I want to find this is the main equation. So what we will do, it is a combustion reaction, it is also a combustion reaction. So solution of the equation, let's find out. So if I talk about this one equation, that is what, that is having the 2 carbon. Alright, 2 carbon, there is no 2 carbon. Alright, there is a 1 mole. Here we are having the 2, there is a 2, so here it is not 2. So what we'll do, we will second equation, we will multiply the second equation by 2, and third equation by what, by the 1. Here you can see we are having the oxygen. Alright, here we are having the oxygen, that is also the same. Here if we talk about the H2, that is here same. Alright, and carbon dioxide if we talk about, so that is also having the 1 mole. Here it is also having the 1 mole, so it is H2 is there. Oxygen, alright, here it is oxygen, so it is one oxygen, so which means like O2, so that is also here. So it is multiplied by the, so third equation will multiply by the 1, and second equation by multiply by the 2, because of this equations. So if I multiply, for example, I'm having the second equation is this. Let's multiply this. For example, I'm having the second equation like this. So what I will do, I'll multiply, for example, 2 by 2 and by 2. So the change of heat is the minus 788 kJ mole, kilojoule mole. Alright, so this was about that I have multiplied by this. And if I talk about the third one equation, so I have to multiply this by 1, so that will remain same because of the 1 upon 2 O2 H2O. Now we have to add this equation, and then we are having a new equation. So you are having the 2 carbon plus H2 plus 5 upon 2 oxygen. Alright, 5 upon 2 oxygen, like O2, that will be what, that will be the 5 upon 2. This is the 4, and this is the 5, so that will be 5 upon 2, and here it will be having the 2 carbon dioxide, this, and plus H2O. Here 5 upon 2 by adding these both oxygen. So we are having the new equation. So new equation is by addition of the first and the second reaction. So the change of heat, if we talk about this, that is 10474 kJ mole. Alright, so if I talk about that by addition of the first and the third equation, now we have to subtract this equation from the fourth equation. Let me write the fourth one equation. C2H2 plus 5 upon 2 carbon dioxide plus H2O. We have to subtract this. Let's subtract by these both equations. So you will find out this change in heat. So for example, the C here will be there. For example, this will be subtracted by this. Alright, 2 carbon dioxide, H2O. So if we talk about the product side, that is the C2, will be the positive, it will be negative, negative because of the sign changes. Alright, and if we talk about there was a change in heat, that was -1299, the same, this one. So what we will do, we will subtract this. Alright, so this will be subtracted by this, so we will see this one. So what will be the reaction? 2 carbon dioxide H plus H2O, and it will move as a product, so that will be the C2H2. So this was a reaction we found, the same as this one, the main equation. And change in heat, let's found, we will having the minus 1299 will be minus by the 1074. So there will be the positive, which means the reaction is endothermic. There is a positive sign, which means the reaction is endothermic, and the change in heat, that is plus 2 to 5.4. So the change of heat is the endothermic, because in this the heat is used. So this is how you will solve the type of enthalpies problem.